everyone, and thank you for joining to this session of Pandas visualization in Python. So basically, we know Pandas as a data preprocessing tool, but it has got some visualization installed in it. So these visualization are made on top of matplotlib library. So we'll basically do something similar to that, and let's see how we can do this visualization. So first of all, let's import relevant libraries. So we need to import matplotlib.pyplot as purity, and we need to import seaborn. Now, why are we importing seaborn and matplotlib? I already said that matplotlib Pandas visualization is made on top of matplotlib, and also when we go to seaborn, if you import in every visualization, if we import seaborn, you are going to make your visualization look presentable. So it's just like that. If you import it, it's going to make your visualization look actually good. Let's import, sorry for this, let's import pandas as pd, and let's import numpy because we want to generate some metadata as np. Then let's make sure that our visualization are inside the notebook. Let's run this and wait for it for a moment. It will actually, it's running in the background, and if you can see here, it's online. I have my free given RAM here, so I'm using 1 GB RAM and 12 GB disk. So that's it. Now let's continue and make a data frame. So let's say df1 is equal to pd dot data frame. Then let's put a random array here, my dimension array. So np dot random dot rand n. So we want random numbers. Then I want 1000 by 4 my dimension array. Then let's put the columns here. Remember how you can build a data frame. We need to have the data, the columns as well. So let's put the columns in here. It accepts a list. So let's put A, B, C, and D here, because we have 1000 by 4. Let's run this. Now once it's done, let's check it out. Dot head. So you can see that there will be random numbers, random values that are presented for us. You can see here they are like that. So let's continue and do visualization with pandas. So the data frame from pandas has got methods that we can actually visualize the data. So for example, if we say df1 and do bracket notation here and just take the values dot hist. So we want to build the histogram. We can just say beans. We want the beans to be 30, but if you remove that, it's optional. It'll actually generate them for you. So you can do this and see you do have a very wonderful visualization. And actually, you can also explicitly say the kind of data frame that not data frame but data visualization figure that you want. So if you say df1 to df1 using a bracket notation, let's grab values from B column and let's plot here with kind, let's say hist. So you need to put it as a string, hist right here, and let's increase the beans to be maybe 50. And let's run this. And you can see you can actually do a plot which you are explicitly saying the kind of the data that you want. Now let's actually shorten this, because I think we can do also a short way of doing this. I can just say df1 and here put c, for example, and I just say plot here dot hist, then run this. Actually, this is good if you want to customize your in the histogram here. If I can wait for it, I think it's because of my internet, that's why it's slow to see the documentation. It's loading, and I think because of my internet is slow. But what you will be prompted here are the other parameters that can help you to customize the look of your visualization. Let's close here. So let's see the head of df1. I want to check the values. Now you see some of the values here are negative values. Now we want to plot an area, let me say area graph. So inside the area graph, for example, if I just say df1 here, I want to show you the anomalies that can actually happen. So df1, let's grab a column and dot plot and dot area. So we want to build an area graph. If I build this, let's see, you will actually be prompted. You see that there's no graph here. Let's check the error. So the warning says that, or the error says that when the stack is true, each column must be either positive or negative. Column A contains both positive and negative values. That's why we can't actually build this, but there's a way around. We can just say we want the head, so that we should have few values to actually say, okay, you know that the data frames have got other methods. We can just say absolute, yeah, abs, and put this function. If we learn this, because we are removing all the negative values to positive, let's see, you can see this is not readable. So we can just say the head. Okay, so if we say the head here, you can see okay, what's the, we didn't put a dot right here. So let's check it out. You can see that the head actually gives you most few numbers to plot, and you can visualize. But I'm not saying that this is actually the case. Or you can use here, you can actually select other values from this, but we'll not do that here. We are not going to slice. So you can slice if you want. There is a parameter here called alpha. So you can just have alpha 0.4. This is about transparency if you just want to make it look cool or something like that. So yeah, that's how you can do it. And we can also use the same criteria with df1. We can actually put select the head only, but I don't recommend you to select the head. You can use the slice notation to slice a little bit of the data sheet, then plot it. So, or you can take the averages or the moving averages. So if you want the bar plot right here, we can actually do that. But let's see if the default bar plot. If we say the default bar plot, you can see they are all over the place here. Everything, the occurrence of these numbers. of these columns. You can see the first columns and whatnot. You see the A, B, C, and D, the occurrence of these values in such column. But I can just say stacked equal to true right here. Then learn this. At least they are actually readable, and you can actually visualize that this thing is readable. If we remove this, let's see what will happen. That's why we are saying it's taking too long to load here, because we are dealing with thousands or 4,000 of data cells. So just make sure that you are learning these things in a very fast PC. And here on the free version of Google Labs, I've been given 2 GB, I think, of RAM. Now, if you see, if you look at this, you are seeing that there are lots of data. You can't even read right here the occurrence of these values, because there are thousands of bars right here. So in this case, there are thousands here, thousands. I don't want that. That's why you have only selected the head, or you can slice it if you want. Now let's take a look on the histogram here. We have already talked about this before. So the histogram, we have already talked about that. I'm not going to talk about that. But let's talk about the line plot. So let's just say df1 dot head. We want the head, and we want to plot, and plot, we want to put line. Now inside the line, accept the x and y value. So I want the x value to be a and the y value to be b. Now if I learn this, let's see what will happen. You can see this line are not in a good way, because you can actually see that we have just made datasets that are not actually correct, because the relationship is just everywhere. These are random numbers. And you can also add other parameters here. The fig size, to be, so it accepts a tuple, so we can just say 2 by 3. We can also add the line with it, so that it should be small. We can just put it equal to 1 LW line with it, so you can see we have actually increased the figure. Let's also finish with some other figures. I think there are 5 of them that we actually look, and the first one is the scatter plot. So we have seen this before. So df1 dot plot and the scatter, and they also accept the x coordinate and the y coordinate. So if I say x is equal to c and y is equal to d, then also we can put this in reference to another variable. We call it c. Now c actually, it maps the value of the color depending on the value of a. So check it out and see how you can actually get hang of it. And you can put the color map here to be c map to be equal to Kubom. Remember Kubom from Seaborn? Yeah, it works like here as well. So if we learn this, let's see what will happen. You can see we have a scatter plot, but however, it's not a very common scatter plot. We have color maps that are mapped at the value of a right here. So check it out. I'll not explain much because The science behind this is just the degree of the value of A in accordance to the value right here. So you can get hang of it as time goes by. Now you can actually also do something about the scatter plot. For example, if I say df1 and do plot and the dot scatter, so it's a scatter plot. Then we talked about the x-axis. So if we say A in the x-axis and Y in the second axis right here, so let's just put B here, not capital B but B. Then we can say about the size. So if I say S is equal to, now this is the size of the dots, and just say S is equal to df, because if I just put it like S is equal to df1, maybe I want to reference to a certain value of C right here. If I run this, they're going to be very small sizes. I don't want that, but what I can do, I can just multiply by 100 and run this. And let's see, you see, you have increased the size. Anyway, these parameters are there in matplotlib. That's why we have imported that library right here to access those files. And you can also do a box plot as easy as just saying df1 dot plot dot box and run it. You are good to go. You can have the box plots that you want. So yeah, it's taking much time because we are dealing with lots of data and our RAM is just as little as 2 GB. Now let's take a look at example of another data sheet that will help us to draw some other visualizations. So that was df1. Let's put df2 is equal to d dot data frame and np dot random dot rand n and 1000 here by 2. We don't want other columns as well to increase our data set. Then light the columns right here and put in here A and B. Let's run this. So wait a little bit. I think we are done here. And let's check the head. Let's run this. You see that we do have some other data sets right here. And let's do the hex bins. So the hex bins, the same as heat map, but actually they are like hexagons, not like squares. So for example, if we say df2 dot plot dot hex bin, you can actually run the documentation here and you see that there are lots of visualization here, the densities and whatnot, and you can actually check the parameters that they need. You see the pi accept other arguments. You have the line, the KDE, the histogram, hex bin, density box, bar, and bar area and whatnot. We have already seen this, but let's talk about the hex bin. And the hex bin actually accept the x and the x, let's put A right here, and B, Y, let's put B, and let's increase the grid size. So it accepts that value, say the grid size, and let's put the grid size value right here, and let's put it to be 25 and add a C map to be equal to cool warm. learn this. Let's see, you can actually see the hex bins. There's a relationship between B and A. So A is right there, but that's, I think, the aspect ratio, that's why we can't even see it. But you can see here the subplot X label A and Y B. It's able to do that for us, and we can actually check the hex bin, and you see the higher the intensity right here at the point here, there are lots of these numbers. They are closer to 0 rather than right here. So that's what it's saying. Let's go to KDE plots. So these are the last plots that we can actually do here. I think that's the most relevant points. So you can just say A right here. You can see I've already selected A, because you can use dot notation right here and plot dot KDE. Let's learn this. According to my internet, I think I've been disconnected to the server, but let me check my connection. Let me check my connection. We do have some internet problems. Yeah, we're trying to reconnect. So our internet is back. Let's learn this. Okay, what's the problem? It's not D3, it's D2 right here. Let's learn this. And you see we do have the kernel density estimation, and there is another one called density. It's actually the same thing. So if we copy and paste there, and right here density, and you see the plot, and you see it's the same thing. And you can actually remove the dot notation and plot for the whole thing. Yeah, you can plot for the two things. So this thing, let's put and also plot for the density, and let me show you that it's the same thing. And let's see right here the plot, and you can actually see it's the same thing. So anyway, Pandas visualization actually just helps us to let me reduce the zoom here. You can see that this library actually helps us to visualize some other data as soon as possible if we are working in pre-processing mode. So it just helps us to visualize those data sets, but it's not that professional. So make sure that if you are doing professional visualization, actually consult other libraries, for example Matplotlib or Seaborn, to have better and fast and also some crazy visualization. So anyway, thank you very much for your time. Next up, we're going to learn about Plotly, very powerful visualization tool. So thank you very much, and see you next time.